So, if we take a look, our header, right, doesn't really give any information away. Instead, it just simply says defining y is equal to kx. Now, this, what we're going to talk about, is a very special type of equation. And in order to talk about it, we actually have to restamp a few things. The first one is, what does it mean to be proportional? And so if things are proportional, there is a constant unit rate between quantities. Make sure that gets silenced, please. There is a constant unit rate between quantities. Now, we've seen examples of this already. If you think about the Explorer, it was cups of rice per person, spring rolls per person. Unit rates are always some unit per a second unit. Right? And so I'll even change this to first unit per second unit. And we'll see examples of this almost immediately. Up next, your independent variable. We've used independent. We actually have been using dependent. We just haven't stamped them. And so on a graph, right, this is x. This is simply the value that is being manipulated. That is the value that is being manipulated. And so, if we think about this, right, think about your equations. Do you remember y equals mx plus b? Yeah. And so, if you think about trying to figure out what that y value is, you actually can't figure out y unless you know x. Now, another word for independent variable that we'll see, especially when we start to do functions, which is unit 3, it's the next unit that we see, we sometimes call this an input. Again, it comes up a lot with function work, but this is an input. Now, if our independent variable is an input, the dependent variable, everybody, is a? Okay, good, we're there. Now, for the dependent, we know that we use y, right? I even said it in the example talking about x. And specifically, this is the value that depends, a little bit out of the box, on the value of another number. The value that depends on the value of another number, right? We had said, I can't find y unless I know what x is. Y literally depends on whatever x is. Okay, and so lastly, this brings us to direct variation. Now, that y equals kx, that's a direct variation. This has a very specific definition when we think about slopes and equations. So a direct variation is a relationship between two quantities where we can multiply the first to find the second. And so it's a relationship between two quantities where we can always multiply the first. I'll be more specific. I'll add them here by a constant to find the second. You can multiply the first by a constant to find the second. And so we didn't realize it at the time, but if I then go back to, right, cups of rice per person, what were we always multiplying the number of, or the cups of rice by to get how many people it was going to feed? 3. And so 3 in that case was our constant. You always took the number of, or the cups of rice multiplied by 3, that's how many people were getting fed. And so that was a direct variation. Now, in terms of their equation, direct variations look just like how we saw up top. They're really specific. We have, I'm going to use a few different colors to sort of illustrate this. Y is equal to K X. Y is equal to Kx. Now, X we know is the independent variable, and in fact we even know that Y is the dependent variable, right? That's what we literally just defined, not 2 inches above on the paper. The semi-new player for us here is K. K is what we call the constant of proportionality. It is the constant of proportionality. This is often abbreviated as COP, the constant of proportionality. And it should look somewhat familiar, right? We already named y equals mx plus b. In this case, we have y equals kx. What we're going to find is that k and m, right, slope that we talked about yesterday, oftentimes behave very similarly. There are a lot of similarities between those two. We'll find that graphically, they're the same thing. And so, we have to make 2 notes here. One, under direct variation, I need us to know all direct variations must go through 0, 0. It is a popular question on a test, a quiz, or an IA for them to ask you which of the following is a direct variation, and they'll show you 4 graphs. Anything that does not go through the origin is not a direct variation. Now, the second note is we have this wonderful y equals kx. And we have this awesome constant of proportionality piece. But the thing that I need us to see and know, because we're about to use it, quite frankly, is, well then, how would we actually figure out what that number is? And so let's think back to our time of using literal equations. If I wanted to isolate k, raise your hand, what would I do? Kyle? Say again? Minus x. I think we're really close. I think right now, kx is what operation? Charles? That's multiplication. 100%. And so instead of subtraction, we just want to shift to dividing. And so we would have, okay, divide both sides by x. And what we learn by doing this is that k is actually y over x. This is very important and something that we will use. Once you have these definitions, flip your notes so I can see, please. Flip your notes so I can see, please. Good. My keys is there as well as there. KK is there. Again, if you're still writing, that's fine. Take another 15 seconds. Make sure you got these. Should make sure heads up. Pile the head up, please. All right. Now we're going to look at an example. Now, I'm admittedly going to go through this example pretty quick because we've actually talked about all of the parts we need for this. This is just a matter of plugging in numbers now. And so, who can read this example about Adina nice and loud? MJ, nice and loud, please.
Adina times herself typing and
All right, thank you very much. So, a few really important things. We know 90 words in 4 minutes, 135 words in 6 minutes, and we're actually told right away this is proportional. This is proportional. That's huge. That actually cuts what we have to do, or the time we have to spend on this, almost in half. And so, well, all right. Complete the table. I know, based on our Explore, that we can actually just end up multiplying this by some value, right? And so remind me again, on the Explore cups of rice, what do we multiply by? What number was it? 3, yeah. 3, as we talked about, would have been that equation's constant of proportionality. And so what that means is I have to multiply by whatever k is to go from minutes to words. Okay, well then let's just find what k is. K is equal to y over x. We already named that. This problem is telling us, oh, minutes are x, so that's our independent variable. Words are y, that's our dependent variable. And so if I want to find this, I'm going to take one of the pairs from the word problem. And so I'm going to say, okay, well, that means that k is actually 90 over 4, right? I'm just using those two values that they tell us. Anybody with a calculator? 90 divided by 4. Raise your hand. What is it? NJ, very quick. 22.5. Now, the follow-up here, what are the units on this 22.5? This is 22.5 what? Is that high? It has to do with words. Let's think about this. Words is a good start. This is our unit rate, right? This is our unit rate. This is 22.5. This is our unit rate. What did we say a unit rate was going to look like in our notes? What did we say? We literally wrote it out on the other side. Eden, say it again louder. Yeah, I know first unit per second unit. This is 22.5 words, okay, per what? What? Unit. What's the unit? Minutes. This is 22.5 words per minute. And so this is what I'm going to multiply by, right? Once I divide y over x, that's what I'm actually going to use to multiply against everything else in this table. So it's really times 22, there we go, 0.5 for 22.5. 2 times 22.5 should give me what? Put in the calculator. When you've got it, just say it. 45, thank you. And then 3 times 22.5, again, when you've got it, say it. 67.5. And so now I can actually go through and find any word length based on the time that she's been typing. Okay, well, I want to take this one step further because you can see part B underneath says, okay, well, what would this actually look like if we wanted the equation? What would this actually look like if we wanted the equation? For that, I'm going to shift down. We know that k is 22.5. We also know that these look like y is equal to kx. Raise your hand. Which one matches the information that we know? Janaya. Is it C? Do we think? Do we agree? No? What do we think it is then? A. What's the... Raise your hand. What's the difference between C and A? Yeah, Janaya. Yeah, so really making sure that we have that multiplication happening instead of that addition. All right. I know that I'm going fast. What questions do we have right now? We're going to do 2 more parts and then close out notes. All right, then. Part C, show the equation you chose is true for typing 135 words in 6 minutes. And so we're now essentially doing a prove it, because we named earlier that I could use whatever pair. I happen to use 90 and 4. This moment I'm going to use 135 and 6. And so, if we know that x is time and y is words, 135 is what variable? Janae? That's our y. So y is equal to 135, which means that for 6, this is what? X. X equals 6. All we're going to do, plug this in, right? This is we've practiced finding solutions before. Let's see if this works. Okay. Y is equal to 22.5x. So that means that 135 is equal to 22.5 times 6. Hopefully this works. In your calculator, multiply them. What do you get? Sorry. 135. And so I end up with 135 is equal to 135. First question. Is that a true statement? Yeah. Yes. And so, does this work? Yes. Yes, it does. All right, we've proven that it works. Now, part D. 12 minutes. What variable is that? It's minutes, so it is x. X equals 12. And so y is equal to 22.5 times 12. Raise your hand when you get this one, please. Put it into the calculator. Put it into the calculator. Raise your hand. What do you get, MJ? 270. Y equals 270, which means she can type 270 words in 12 minutes. All right, again, I know I went fast. What questions do we have? All right. Louder. 22.5. How do we get that number? How did we end up getting that number? Janaya? Absolutely correct. We knew from up here, if I want k, I have to actually just take my y value and divide it by an x value. They need to be the adjoining one, so it needs to be like a coordinate. However, when I do that, I get what's called that constant proportionality. And so that's the thing that I can multiply any x value by to always find the y value. In this case, we had 90 and 4. Simply just threw it in the calculator. 90 divided by 4 gets us to 22.5. That 22.5, right, that means that k was equal to the 22.5. This is what we use for every other part of this. Good question. Any others? All right, you got 1 minute. Fold these. Get these glued into your notebook, please. Go.